would represent my group to show you the solution to the part 2 of the assignment 1. Before we jump to the simulation part, which is an interesting one, I hope that you would bear with me with the explanation part. It's a little bit boring, yeah. And for the explanation, for this script, we import two modules. The first module is a robot control class module from the construct scene. And specifically, we import the robot control class, which contains several methods to manipulate with the robot. And the second module we imported is the math module. This is a built-in module from Python. So the variable A, we assign it with the value from the get laser method. And this method, we substitute the 360 as an argument because in the previous chapter, it's mentioned that the laser in this robot, it would send out many beams ranging from 0 to 790. So in order to measure the distance from the robot to the right in front of it, we should use the 360 as an argument. That is the reason why we substitute here 360. And so for in order to let this guy escape the maze, we do the pattern analysis, and we notice that from the starting point to the first turning angle, and from the first turning angle to the second one, the robot would turn to the right. So from the second turning angle to the third one, the robot would turn to the left. So it should be another pattern. That is the reason why for the first for loop, you can see here, it only contain two iteration. Yes, the first iteration is from the starting point to the first turning angle, and the second iteration is for the first turning angle to the second turning angle. So I assign the variable f equal to 1 because I want to bring out the round number where during the operation to let the user know which is the current vending process. And inside the for loop, I have a while loop, and this while loop would have the robot moving straight forward as long as the distance from the robot to the world is larger than 1. Yeah. When this condition didn't satisfy anymore, so it would exit the while loop and stop the robot. And after it stop the robot with the stop robot method, it would we would call the rotate method, and we substitute the a positive value is 80 to have the robot turning to the right. Uh, because as you may know, the coordination of the construction platform is not really precise. So we have to do some trial run to get this optimal value. And after it turning to the right, we reset the value for variable A by calling the get laser method again to let it ready for the next iteration. Yes. And after the robot finish it, the second run, it would be somewhere here and facing to this direction, to this world, So so it will turn to the second part of the script. We call we call the I value, I variable equal to 3, and we want to bring on the screen the third. This is the third round. Yeah, it would run from the second position to this third position. This time, well, we only use only one while loop. This have the robot uh, moving straight forward as long as the condition is the condition for variable a is larger than one. After after reach here, is the robot would like yeah after reaching the robot would rotate after reaching here the robot would rotate to the left, so it should be minus 95 degrees. Once again, we come to this value based on the experiment. We do some trial run and to get this optimal value. And after it turned to the left, um, the robot is ready to get out of the maze. So I reset, once again, I reset the value for variable A by calling the get laser again, get laser method again. And then we try to use the try and finally concept to have the robot get out the maze. So this time we use a function check. It's called to check this whether the value for a is an integer or infinity value. Because when it reaches here and it facing to this direction, uh, the distance would be an infinity. So I would call the math function to check this statement is true or not. If this is true, for the try clause, it would like manipulate all of the corresponding commands below. And for the try clause, uh, we bring some information to the screen to let the user know and get ready for the finally clause that we just move you call the move straight time method, and we input the direction is forward because now it's just only one direction, and the next argument is for speed, and the last argument is for time, the duration. Once again, the last two arguments for speed and duration, we also do some trial run to get the optimal values for them. So now I think we would test for the simulation part. This is maze dot button, and yeah, as you can see, this is the first round, and when it reach here, yes, the robot would turn to the right. Yes, and turning, and then on to the second round. When it reach here, it turning. Display the column distance turning to the right, and then for the third round, in reach here, it's turning to the left. Just turning to the left and checking for this the infinity value, and then you just get out of the maze. Yes, that's all for the solution. Hope you like it. Yeah, have a good day. Bye bye.